Welcome back after a short break. Now we are starting another presentation. I'm together with Anshul Sharma, who is Senior Product Manager at Microsoft, and Paweł Potasiński, who is Senior Program Manager at Microsoft also. And the guys will deliver for us presentation about Kusto, also known as Azure Data Explorer, and how to use them and how to understand what analytical scenarios can Kusto address. So the guys will make a show and demos for us. And I believe that it's the most important about your presentation. And if you will have any question to guys' presentation, don't hesitate, just write them on the chat during their presentation. Guys, the stage is yours.
Okay, thank you, Mateusz. Welcome, everyone. My name is Paweł Potasiński. Anshul is with me. The flow will be like this. I will present some slides just to introduce the product. Then Anshul has the major part of this presentation covering some nice demos, showing the value of the product, which I believe is one of the most powerful platforms Microsoft has in analytical portfolio. And then we have some recap and some homework for you. So we won't leave you just with the slides and demo, but also with some link, just a single link for you that will be helpful if you want to learn Data Explorer and expand your knowledge. So with that, let me just quickly introduce. The purpose of this session is to give you a high overview of what Azure Data Explorer is, what are the scenarios, what kind of data you should handle using this service, and then show you the real power behind the service. So as Mateusz mentioned, this service nickname is Kusto. And why? Because we refer to Jacques-Yves Cousteau, who is the Ocean Explorer. So we believe that Data Explorer, the Azure Data Explorer service, is the explorer for the ocean of your data. And that's why we named our service with Kusto nickname. You will see Kusto showing. It's used just as the product name at some point, but the real name of the product is, of course, Azure Data Explorer. So Data Ocean. Now, every single good product has to be tested before it actually is released. So guess what? We tested this Data Explorer on our own. It started with Power BI. We needed a tool that will allow us to scan and effectively analyze petabytes of logs behind Power BI to make sure that we are able to locate the problems for the users and quickly eliminate those problems. Over time, it appeared that the tool was so good, it was adopted effectively by other teams and other Microsoft products. So actually, right now, you deal with the service that has been used by many Microsoft teams sitting behind different products like Windows, LinkedIn, Visual Studio, or Xbox. So variety of different platforms. Over time, it appears also that we were able to produce software as a service solutions based on the same platform. So for example, if you play in Azure with Azure Monitor, Log Analytics, or Application Insights, then you will benefit from Azure Data Explorer under the hood. And what's more important even, you will use the same KQL language to query your data. So in general, if you learn Azure Data Explorer, the knowledge will expand to different Azure services. And it's not just about pure observational analytics, but also it covers different aspects of working with Azure and data. Now, we have a bunch of satisfied customers, really happy to use Azure Data Explorer. If you want to find some of them, I encourage you to visit aka.ms/adx.customers. And especially from this screen, I would encourage you to look at Bosch example, because it shows how Azure Data Explorer can easily integrate with other Azure services, like Azure Functions, for example. Now, what actually this Azure Data Explorer is? Well, the definition is that it's a big data analytics cloud platform optimized for interactive ad hoc queries. But reality is this: if you have not even big data, but the data that is like coming quickly, changing quickly, doesn't have static schema. For example, JSON documents coming from different APIs or I don't know, applications. if this is like time-based data, then Data Explorer may be the best solution for you. Cloud platform means that it's optimized for use immediately with your data. So you just grab the data, put it in the platform, and immediately can interactively play with the data, getting access to the data, running analytics. By analytics, I don't only consider analytics like aggregations. It's possible, but also very, very complex analytics based on text search, operations run on time, like time series analytics, anomaly detection, or forecasting. So this thing is actually constructed to get even petabytes of data with no static schema. It will infer schema for you if you want, and it will allow you to query the data even if it contains some textual descriptions, JSON elements, etc. Okay, and it's gonna guarantee you fast query times, which is super important. Now, the scenarios that will be covered by this service. The examples are this: if you have anything that comes with big telemetry, like smart factories, signals coming from different devices, like smart buildings, collecting who enters which room, for example. Like logs. Well, that's the most obvious because that's where we started. But IoT devices sending different signals. You want to monitor the health of the patients, whatever. If you have click streams, so hey, if you have a website that comes with the messages sent from the UI, who is clicking where and how people use your user interface, that may be a good idea to use Data Explorer as well. And based on our own products, like security part of Azure, you can also use it for security monitoring and threat detections, right? So to wrap it up, if you have data that based on time concepts, so you want to analyze time series, data represented in time. If the data is immutable, so it lands in your platform, and then you want to immediately analyze it, but you don't change the data, it only appends. If the data has high frequencies, maybe streaming, if it's in high volume, yes, we will show you some examples that have some stunning numbers behind. If it's not just structured, not just tables, but also semi-structures like JSON or free text, you will see some amazing stuff there. And if you need low latency of your queries, that's going to be a scenario for Azure Data Analytics, which makes it quite a lot of scenarios. Remember, it's not just the real-time analytics, because you may have any data, put it in the Data Explorer, and find amazing insights in the data. I will give you one example, actually. Imagine you have a bunch of even text files sitting in a data lake. You can load this data in Data Explorer, and easily, using those free text analytics, you can find where the customer's data sits, in which specific files, in which attributes, even if the files have different schema, right? So again, there's a big power behind this service. And again, you may construct things that will be also real-time analytics as well. Now, to make it easier for you to understand why the service is powerful, the architecture is quite complex because, hey, it's a distributed environment sitting on some clusters, nodes. It contains SSDs attached to worker nodes, which do the job for you. But hey, you don't see this complexity. You don't see this complexity. There's a service. You put the data in the service. It does all the magic, and the only thing you have to handle is querying, maybe setting some policies on how long your data will sit in the platform, and what will be the caching strategy. Other than that, there are no knobs, no tweaks. You just have the platform that responds in seconds or milliseconds. Now, having said that, notice that it can take not only data from Microsoft platforms, but also from different platforms like open source. Kafka is a good example. Also, consumption of the data coming from Data Explorer can be done using open source technologies, Jupyter Notebooks, Grafana, whatever you need. you can integrate Azure Data Explorer with your whole data ecosystem, not only based on Microsoft technologies. And that's the most important outcome of this slide, not the complexity of the platform, because we cover this complexity behind the service. Now, KQL, that's the biggest part of Anshul's presentation, Anshul's demo today. So just a quick look at this querying language. If you know SQL, the good news is that some queries, not all, but some, may be translated from SQL to KQL easily. We have explain command for you, but really it's an intuitive way to query the data. You just put the name of your table, so it's based on tables. It's rich. It has functions that you will miss in some SQL languages, and you will see some examples in Anshul's demo. It has built-in search, it has built-in regex, it has built-in time series analytics, etc. And the good thing about KQL, which I like the most, is that you start with a table, and then you just put the statements or element of the statement in the order just like you think about querying the data. It's different from SQL, but it's not different from how people think about querying data, which you will see in a second. And also, as I mentioned, the big part is that you can easily move from SQL and expand your knowledge to KQL, because we have cheat sheets for you. We have explain command for you. There's bunch of helpers that allow you to move from SQL to KQL. So with that, actually, I will wrap it up with some numbers. Imagine that we are using this platform to handle exabytes of data, almost 14. I believe this number is growing right now because it's changing all the time, because we ingest 160 petabytes of data daily. 3 billion queries per day. All those queries are fast. And, growing number of KQL developers. I hope we will see some of you also joining this great community later on. With that, let me hand it to Anshul, who will show you some power behind this really exciting platform.
All right. Thank you, Paul. That was a great intro. In the next few minutes, what I'm going to walk you through is basically a quick demo of the analytical capabilities of the platform. And I'm just going to share my screen. But in terms of how we will go about it, we'll show you some queries around some interesting data sets. We'll try to show you the different data sources from which you can bring data in. And lastly, also allow you to create your own free clusters by sharing a link for you to get started. With that, I'm just going to share my screen. I hope it's visible. All right. So what you see on screen is the web interface to interact with ADX or Kusto. So this is the home screen. Out here, you can see there are a bunch of options available to you. But very quickly, there are a few tabs, as you can see here. I'm going to give you an overview of the data tab, which is basically one place for you to bring all your data in, whether the data exists on your local file or in a blob container on Azure or event hubs, or even like, for example, if you are an AWS user and your data exists on AWS S3, you can easily bring that data in with just a few clicks, right? So these are some of the options available to you. I'm not going to go in detail on each of those, because primarily we are going to focus on the query capabilities today. So what you see is I've changed my context to the query screen. On the left-hand side, you can see some of the ADX databases and clusters that I am connected to. For this demo, we are going to see a bunch of data sets, but let's start with one of the interesting data set, which I personally like, is GitHub. So if you are a developer, you have dealt with GitHub. So this table, I have a database called GitHub, and this few tables, starting with one of it called as GitHub event. Basically, it includes all the actions that as a developers you take on a GitHub repo, whether you're pulling, whether you're pushing your commit, whether you're writing any message, whether you're forking, all of that data is emitted as a telemetry data point. And we have this live feed that is coming in, which is ingested in this particular table. So very quickly, I'm just going to run a very simple query which says table name and count. What it does is it returns the number of rows that exist in this table. You can see there are approximately 1.2 billion rows that we have in this table right now. In terms of how the data looks like, again, I'm going to take a quick top 10 records or sample of the data. So if I run this command, say take 10, this is the data that exists, right? You can see there are a bunch of columns here, starting with ID, type, which is which type of event it is, whether it's a push event, whether it's a watch event, and so on. There are some interesting columns as well, like actor, repo, which you can see is not structured text. So if I open this, this is basically unstructured text, right? It's a JSON document that exists in this particular column. So this is where ADX not only supports structured data, but it also supports unstructured data like JSON. And we'll see how you can analyze all of this at scale. Quickly, one of the other queries, what if I'm interested to see, I have a date column in the database. I'm interested to see what's the minimum and maximum date for this particular data. You can see that I have events coming right from 2016 all the way to 2019. And it took like less than 300 milliseconds to calculate this in 1.2 billion records. You can imagine the performance that you're getting out of this. Moving forward, we can not only visualize the data in a tabular format, but with ADX, you can also create visualizations very quickly. So this is a query wherein I'm summarizing the count and also bucketing it in based on 1 day. So all I'm saying is give me all the records created per day and show that in terms of a time chart, right? So if I run this, you can see there is a nice little time chart that has been created. I can hover around it at any given day and see how many records have been created. So approximately 1.2 to 1.4 billion records, 1.2 million records are ingested every day. Moving forward, if I have to see what's the data size of my table, that's the query that I run, and the output is there is approximately 3.3 terabyte of data that was ingested. And this is an interesting thing that you are seeing here. So when you ingest data into ADX, by default, the engine offers you a compression, right? What it means is, in this case, we have ingested around 3.3 terabyte data, but after compression with our algorithm, it became around 0.74 TB. So I think it's less than, like it is like 4x. So you got a compression of around 4x, or maybe 4.4x, 4.5x. So for you as a customer, you only pay for the compressed data, right? You do not pay for the data that you're bringing in. So that's the value add that you get. And of course, the performance is going to be a lot faster because now you are running your queries on top of this compressed data. Again, like just reminding you, you can always ask questions. Please keep your questions coming in the chat. We'll try to answer them at the end. Just moving forward, we saw a few of the, again, just to remind you the structure of the table, you can see we have a column here, actor, which is not a structure column. It includes a JSON, which has few keys, for example, display login, and so on. So what if I want to analyze some of the data that exists in this unstructured column, right? How can I do that? Well, it's very simple. You can just use it as you would use unstructured data, right? Like if you use JavaScript, basically you can use like column name dot the name of the key, and when I do that, it will return me the value of that JSON key, right? And just I'm returning only top 10 records. So you can see it's very intuitive, it's very fast. You don't have to worry about flattening your JSON or unstructured data. You can easily play with it. Now, what if I want to count the distinct usernames that exist in this particular database, right? So we'll still use the unstructured column to get the value, but we are using an operator called dcount. So what dcount does is think of it as allowing you to retrieve distinct count. So in this case, I have approximately, I think 16 lakhs unique users in the system, and it was returned like within 2 seconds. Moving on, we can have additional interesting queries. Like for example, if I want to see what are the interesting event counts that exist in my data. So if I run this query, you can see push event is probably the largest amount of data that exists, followed by create event, then pull, poking, and all these actions, right? So this gives me additional insights on top of this data, like what users are typically doing with GitHub. Let's also visualize this in a nice bar chart. So you can see I said like render a bar chart, and the same data is returned in a more visual manner. So I can see push event is the most popular type of event, followed by create event, watch event, and so on. Again, we can look at different type of visualization. This time I will show the information in a pie chart. So you can see the same information is available in different type of visualization for you. All right. So this is how you work with KQL. As you can see, it's very intuitive. It's very powerful. But if you're coming from SQL, you might say, hey, I'm used to working with SQL. How can I get started? So for users who are coming from SQL, what we also allow you to do is use an operator called as explain. So you can still write your SQL queries the way you do today with your SQL tables and just run this explain operator. What it does that it gives you the KQL equivalent of your SQL query. So in this case, you're saying select count from table where type equal to push event, and it converted it into a KQL query. And now you can copy and paste this query and execute it, right? So this is for users who are coming who are not familiar with KQL. This can be a good learning ground. This can be a good way to start learning about KQL. There's another example, but I would move on to some of the additional advanced analytic stuff that you can do with KQL. So you can not only run basic queries, right? But as Paweł mentioned, we also have some built-in advanced ML forecasting functions as part of the platform. So in this case, for example, if I'm interested to know, detect some anomaly based on the data that exists in the table, how would I do that? So there is a inbuilt anomaly detection function that exists. So you start by filtering on the data that you need. In this case, I want to look at all the push events. I want to look at all the events that have Azure in the payload and create a time series out of it based on a specific range, and then just pass it to this inbuilt function and render it with an anomaly chart, right? So it's you don't have to be a data scientist to get this advanced analytics out of your data. You can use this inbuilt function, and you can see it created an anomaly chart and also highlighted some of the anomalies. So the points in red are anomalies, and I can just quickly hover over them and see why they are anomalies, right? And which value is causing this anomaly. So again, like you don't have to be a hardcore data scientist to get value out of your data. We have thousands of inbuilt functions through which you can get started very easily. Another example is around forecasting. So if I want to forecast what are based on the past event in my data table, what is the future events going to look like, right? So I can still follow the same pattern. I can give a query, create a time series out of it, and use another function called series decompose forecast, and it will forecast the values in the future based after my data set ends, right? Like in this case, the blue line is the chart based on my existing data, which ends at this point of time. But the orange line is the forecasting that has been done based on the historical data that exists. So it's very powerful, and you can see it's very easy to create this additional visualization and charts just with a couple of lines of code. Yeah, just that was one of the interesting data set. We are just quickly going to switch gears, and I'm going to show you another data set. This time it is more about logs. So I have this another data set called in another database called SQL BI. And this is even bigger in terms of size, right? Like you can see approximately this database contains 40 terabyte. And one of the table here called BI Azure Trace is including like it has like 22 terabyte of data. So it's kind of a huge table. Just in terms of how huge it is, it includes like around 41 billion rows, right? Which is like like 40 times more than what we saw in the GitHub event. So it's really a large database. Now, in terms of what the data structure looks like, this is the data structure. It's a typical log table wherein you have timestamp, you have level of your logging activity, you have your PID, TID, and then you have free text, right? The text here is kind of free text. Basically, you have a bunch of information here. And then at the end, you have a column called event text, which is nothing but like think of it as your stack trace, right? So this is really not even semi-structured data. This one is really unstructured data, which is a free form text. And now we'll see how you can even analyze it with ADX. So I'm going to run another query which says within this table, within the timestamp, which is like between 2015 month of March and month of April, give me the number of rows and divide them based on the logging level, right? So you can see this query was executed within a second, and based on the logging level, these are the number of rows that exist. And a cool, nice little neat trick here is based on your logging level, whether it's verbose, whether it's error or warning, there's also some color coding that the platform provided for you. Just quickly moving forward, for example, if I'm interested to see within a specific time frame based on my level 2, which is like warning or error, give me the sample events that exist, right? So in this case, the specific role is facing this kind of errors. In the event text, you can see that. So as an analyst, or as let's say you are an on-site engineer who's supposed to debug a specific scenario, let's see how you would do that. Now, there are a bunch of other operators that exist in the platform, such as parse, as well as some other stuff. In this case, you can see the role, the specific structure. So what we can do is we can use the parse operator to pass the value in the role with a specific column, right? So all we are saying is give me only role only and give the data, like split the data after the dash. So if I do that, you can see the data was returned, and these are the values that were returned, and these are the top 30 kind of, it's just a sample top 30 rows that are returned by the platform. Quickly moving forward, if I'm interested to look at the error distribution based on role type, there's a simple query which allows me to do that. Like it allows me to summarize the count based on role type and also bin it based on 10-minute interval and render it in a time chart. So if I run this query, okay, so my bad. If I run this query, you can see it created few time series. And if I hover on that, you can see a specific role count is having more errors versus others. And as a user, it becomes as an analyst, it becomes very intuitive for you to understand which users or which specific role sorry, is having the most issues. Just quicking, like I'm going to skip some of the basic queries and show you like the most interesting stuff. Like if you're used to working with regex, we saw the value of the event text is kind of a free flow, right? But what if you are interested to even extract some values out of it? Because it's free text, we allow you to write regex on top. So you can just create a regex based on your data. And we are passing like user ID based on the huge event text free flow unstructured data that exists and returning it, right? So in this case, I'm saying pass the user ID based on this regex. And if I scroll to the right, you can see out of all that text, it was able to parse the user ID and also return it within few hundred milliseconds, right? So you can imagine it's working on a 40 terabyte data set and it's running this regex, but still returning the results for you within milliseconds and seconds in some cases. And one of the other interesting example is now you have this bunch of ocean of data as Paweł talked about, but you want to understand who are the users who are getting frustrated more, right? And how you can do that is basically look at which are your users which are facing the most errors, right? And maybe you want to give them an offer, maybe you want to course correct and help them out to navigate the situation so that they don't churn based on your business. But how do you do that? Basically, what you can quickly do is within your table, you can again parse the user ID based on the query that we wrote previously. But now what you can do is you can summarize the count of errors based on a specific level and just show the top 10 users who are frustrated the most based on this, right? So in this case, I ran this query and user ID ending with 7D has faced around 2000 plus errors. So looks like it's the guy is really struggling and maybe he or she might be frustrated, right? So that is how you find a higher level insight. But what if I'm interested to dive deeper, right? What if I'm interested to see what are the exact errors this user is facing in order to understand?
Anshul,
Yeah.
One last query.
Okay, one last query. Okay, perfect. So this is a nice query because now we know who the frustrated user is. What we can do is we can even drill down by providing that, by passing the same thing, but also providing that user ID. And once I do that, and if I run this error for that specific user, you can see these are the top errors that that user is facing, right? In this case, database does not exist. This is just an example, but you can imagine how you can identify the issues faced by some users and definitely act on top of it. Yeah, that's all I wanted to show in the demo. One last thing, if you're interested to learn about this, Paweł will show how to get started. But you can visit this link called aka.ms Kusto free, which will land you to this particular page. You can claim and create your own cluster, which is completely free of cost. You don't even need an Azure account to work with, and start playing with some of the scenarios that we just talked about. Yeah, over to you, Paweł.
Thanks, Anshul. That was great. I hope you got some guts on how Azure Data Explorer looks like and how you can benefit of this service. Imagine 40 terabytes of data and Anshul was just clicking run and things were happening. Awesome. So hey, just to start, we have a single link for you. There is a slide on the screen, but grab only this one link, aka.ms/adx.links, and then you will have everything, including the free way to start playing with Kusto that Anshul mentioned. But that's not all. If you want to have some challenges, because we learn by challenges, we encourage you to go and join the Kusto Detective Agency, which is a contest, or rather a challenge, or a bunch of challenges. You can get some badges, but the most of all, you will learn how to play with KQL, how to deal with big data in ADX, and how to solve real-life problems, like why the heck some of the folks win the voting instead of the really supported person. So hey, I encourage you to join detectives, play with KQL, learn by running challenges. Anshul and the team are behind this great experience of Kusto Detective Agency. We hope you enjoyed this session. If there is any question online or somewhere else, just we are now open to take it. And with that, thanks very much for having us at MS Tech Summit.
Okay, thank you very much, guys, for your presentation. It was amazing, and on the chat I see that we have a question, maybe more recommendation than question. What at the beginning? What would you recommend, Explorer or Synapse?
Both. Actually, you don't have to choose because they are for slightly different things. And I would say this: Azure Data Explorer handles observational analytics, while Synapse is a bit for not only observational analytics, but also for classical data warehouses and lakehouses. And the best part is that actually Azure Data Explorer in preview is a part of Synapse Analytics. So when you start Synapse Analytics workspace, there is a way to spin up an ADX cluster and play with Kusto databases, the same way like Anshul did this today. So okay. you don't have to pick one.
Okay, and I see a request to show once again the link to these resources. If you could, Paweł, show, our viewers will be able to
take the screenshot or note this link, aka.ms/adx.links. I think we will share the presentation in the PDF version as well with the audience later on. So hopefully you will be able to download it as well. But this link works best. It's actually managed by the ADX team themselves, like Anshul and his colleagues. So feel free.
Yeah, and if you have no more questions, please feel free to hit me or Paweł up on LinkedIn or any other social channel. We can continue the discussion even later. Thank you.
Absolutely.
Okay, I don't see any more questions on our chat. So thank you very much, guys, for your presentation, for your answer. Thank you very much for participation in this time slot. And as always, you can share with us your feedback using stars under the video player and rate this talk. So thank you very much, and
Thanks.
see you after break.
Thank you.
Thank you very much.